Example 13. Find the sum of the following geometric progress. Option A, we are going to solve. But before solving it, let's remember what does geometric progress means. Geometric progress is a number of patterns where there's a common ratio between the consecutive terms. Now, as you can see, A2 is equal to A1 times R. And A3 is equal to A2 times R. And instead of A2, can I write A1 times R? Yes, instead of A2, when I write A1 times R, what will happen? A1 times R, then I will result will be A1 times R square. Then what is A4? A4 is equal to A3 times R. Then instead of A3, from the previous step, what I find, A3 is equal to A1 times R square. Then instead of A3, I'm going to write A1 times R square. Then I will get the answer as A4, A1 times R cube. From here, as you see that A4 is equal to A1 times R cube. A3 is equal to A1 times R square. Did you see the relationship between 4 and 3? Look at, this is 4 and this is 3. This is 3 and 2. It means when you do the same step for an minus 1, you'll get A1 times R raised to power n minus 2. Because you are looking for the n minus 1, then you look at the previous n minus 2, just subtract 1. Then the same logic, an will be A1 times R raised to power n minus 1. That is the pattern it goes on. Then another important issue is the series. What the series means? The series is the sum of the terms of geometric progress or arithmetic progress. But for this question, we are talking about geometric progress. S1 means the sum of the first term, which is S1 is equal to A1. S2 means the sum of the first two terms, A1 plus A2. S3 means sum of the first three terms, A1 plus A2 plus A3. S4 means sum of the first terms, A1, A2, A3, A4. And Sn minus 1 means sum of the first n minus 1 terms of our series from A1, A2, A3 till An minus 1. And if I'm talking about Sn, it will be the sum of all the terms till n, means A1 to An. Now when we look at our question, find the sum of the following geometric progress. Now that's what Sn means, isn't it? Because definition of the series. Then just multiply this one with R. Multiplying an equation with R means we are going to multiply all the terms with R for our equation not to be remain to be same. Now multiply with R means instead of Sn we will have R times Sn, and instead of R we will have, instead of A1 we will have A1 times R. Instead of A1 times R we will have A1 times R square. It will go like that. Instead of A1 times Rn minus 2 we'll have A1 times Rn minus 1 because we are multiplying with R. And as a last term, instead of A1 times R raised to power n minus 1, we'll have A1 times R raised to power n. That's what we are going to have. After multiplying, subtract them side by side. On the left hand side, we are going to have, Sn minus R times Sn. Then on the right hand side, what will happen? Look at. Now, take your attention. This A1 minus A1 times R and this A1 times R, are they the same thing? Yes. What will happen? You are doing subtraction. This will and this will go out. And A1R square and AR1 square, are they the same thing? When you subtract this from this, you will get 0. You will continue. And this one will continue from here. And this one will subtract from here. Then you will, what you will have? On the left hand side, only you have Sn minus R times Sn. On the right hand side, you have A1 minus, be careful because we multiply with minus R. Okay, all these ones are minus. Okay, don't forget, just let me correct it. All of them are minus. Now, what will happen? Minus A1 times I raised to power 1. That's what we have. That's what we have. In this step, as you see that's where we reach this point. Now, Sn minus R times Sn is equal to A1 minus A1 times Rn. And because of that reason, do we know we need to get Sn, isn't it? Yeah. Do we know R? Yes. Do we know A1? Yes. Do we know A1? Yes. Do we know R? Yes. Do we know N? No. That's the point. Means we need to get N. what is n? We need to first find n, then move back to this step. Now what is n? Do we know the last term? An is equal to 1458. Is that clear? Now from here it means A1 times R raised to power n minus 1. Means I'll write it like it. A1 times R raised to power n minus 1. Which means A1 is 2 times R is 3 raised to power n minus 1. From here divide both sides by 2. Then what? Just let me write it like that for it to be more clear. 1458 is equal to 2 times 3 raised to power n minus 1. Divide by 2 both sides. Then 729 is equal to 3 raised to power n minus 1. From here this is 3 raised to power 6 is equal to 3 raised to power n minus 1. Then means n is equal to 7. Now we get this point. Now let's look at then we can use this one, what we get here. Now Sn minus R times Sn means 3 times Sn is equal to A1. What is A1? 2 minus A1, 2 times R raised to power n. What's n? R is 3. What is n? 7. Here, then negative 2 raised to Sn is equal to 2 minus 2 Sn is equal to 2 is common here, then we can write it like 2 in a bracket 1 minus 3 raised to power 7. Then we will divide both sides by negative 2. Then Sn is equal to, now these negative 2's will cancel each other but remain as negative, then it will make the up part negative. Then minus 1 plus 3 raised to power 7 means your answer will be 3 raised to power 7 plus 1. 7 then is equal to 2187 plus 1, which means 2188. That is the answer. If still some points are not clear in this solution, let me know. I will try to find another way to explain it.